We're talking about elimination again today. So let's remind ourselves what we talked about yesterday. Remember, there's three methods: graphing, substitution, and elimination for solving a system. When you use elimination, you want to add the equations to eliminate a variable. Okay, so that's kind of the process. We always add the equations together. Now, remember the big thing in the steps that we talked about yesterday. The big thing for elimination is that for the setup of the two equations, you must have the coefficients the same for x or y. One needs to be positive, one needs to be negative. Okay, and so like an example of that, if you remember, they were all the problems that we saw yesterday. Let's say one equation is 2x plus 4y equals 12. And then maybe it's 5x minus 4y equals 6. This is how you want it to be set up. They're both in standard form. If you remember, we talked about that last time too. You want to have the same coefficient. That just means the number in front of x or y. So if I look at the y's, they're both 4, and one's positive, one's negative. Okay, so that's exactly what you want for your setup. Once it's set up like that, then you can go ahead and add the equations and solve for your variables. Now, yesterday we did ones that were set up nicely. Today, these are not going to be set up as nicely. Okay, but we're still looking for the same goal. We're looking for the same coefficients, one positive, one negative. Now, if you look at the system on example A here, I'm in standard form, so I'm good, but I've got 3 and negative 5 in front of x and 6 and negative 2 in front of y. So I don't have the same number. I've got signs the way I want, positive, negative, positive, negative. I need to make the same number happen. So yesterday, when we didn't have things looking like we wanted them to, we multiplied one of the equations to make it happen. That's exactly what I'm going to do here. I either need to make the x's both the same number or the y's the same number. You look for the easiest place to make that happen. If I look at the y's, I see that if I just multiply the smaller one by 3, I'm going to have it being 6 and negative 6. So that's exactly what I want to do. So I'm going to put the entire second equation that I'm changing in parentheses, and I'm going to put a 3 out front. Okay, I want to multiply all 3 parts by 3. You have to multiply all 3. Okay, now I'm just going to copy the first equation down here at the bottom, and then I'm going to distribute the 3 through to the second equation. So that'd be 3 times negative 5 would be negative 15x. 3 times negative 2 is negative 6y. And then 3 times negative 14, remember that you have to multiply even that number sitting on the other side. That's going to give me negative 42. Okay, so I'm not going to use the original 2 equations. I'm going to use the top one and my new one underneath it. Now I'm ready to add together because I see 6 and negative 6. Okay, so 3 plus negative 15 is going to give me negative 12x. The y's eliminate. And on the right, I've got negative 6 plus negative 42 is negative 48. Okay, now it's a pretty easy equation to solve, so I'm just going to divide by negative 12. And I get x equals positive 4. Now remember that you always have to find both variables. So I always need to bring my first answer up to the top. You can plug it into the original 2 or the new one. It makes no difference. I'm just going to go for the very top equation. So 3x, I know x is 4, so I'm going to plug that in. Plus 6y equals negative 6. Okay, so I'm going to solve that for y. 3 times 4 is 12. Okay, now we subtract the 12. 6y equals negative 18, and then divide by 6. And y is negative 3. Okay. On my next example here, same thing. I don't have the coefficients being the same, one positive, one negative, so I see negative 2 and negative 7, 15 and 5. You look for the easiest place. So if you can just multiply one equation to make the coefficients match, that's where you want to multiply. So 2 and 7, I can't multiply 2 by anything to get 7. But I do see on the y's, if I just multiply the second equation by 3, that's going to be 15. Now, notice if I choose 3, it's going to be positive 15 and positive 15. So I'm going to stick a negative there with 3, so I end up getting negative 15. Okay, I'm going to copy the first equation down, not changing it. And I'm going to distribute negative 3 through to the second equation. So that'll give me positive 21x. Check your signs. Negative times negative, positive. Negative 3 times positive 5 is negative 15y. And then negative 3 times negative 17 is positive 51. So be really careful with your signs. Now I'm ready to add them together. So negative 2 plus 21 is 19x. The y's eliminate. And then on the right side, you've got negative 32 plus 51 is 19. Now that makes it pretty easy. X equals 1. You're going to bring it back up and plug it in. You can plug it in anywhere for no reason. I'm just going to choose the top equation again. I know that x is 1. So I'm going to do negative 2 times 1 is negative 2. Plus 15y equals negative 32. And then I'm going to add 2. And I get negative 30. And then divide by 15, and y is negative 2. Cool. Okay, so for C, we got a word problem. Now, think we're doing systems, so you should be writing 2 equations. And we're just going to set this one up. If you feel like you want to solve it, you can do that on your own. Read it first. It says, suppose the band sells cans of regular popcorn for $5. And it sells cans of caramel corn for $8 per can. The band sells a total of 240 cans and receives a total of $1,614. We want to find the number of cans of regular popcorn and the number of cans of caramel corn that the band sold. Now, the last sentence is going to give away your 2 variables. So it looks like I've got regular popcorn. So we'll use R. And we've got caramel corn. So we'll use C. Now you kind of got a lot going on here. Here's what I see. I see dollar amounts and I see a number 240 cans. That's not a dollar amount. So you kind of have to figure out what goes together in what equation. Here's a hint, you guys. If you've got some numbers that are money and some that aren't, the numbers that are money, they go together in one equation. Okay, so I'm going to write like a money equation. You know, it's $5 for regular, $8 for caramel, and they sold this much. So I'm going to put those numbers together. $5 for regular, $8 for caramel, and the total, which always goes by itself, was $16.14. Okay, so that's one equation. The second equation is only going to have one number, and it's the number I haven't used, the 240 cans. I know the band sold that many cans, so between caramel and regular, that's the amount that they sold. So that one's going to be real plain. Regular plus caramel equals 240. Okay, so this second equation was really just about the number of cans. Now, you could choose, probably on word problems, they'll tell you like you can use whatever method you want. So you could do elimination, you could multiply the second equation by -5 or -8, or you could get a variable by itself and use substitution. Either way would work. We're not going to solve it. We're going to flip it over and look at a couple last examples on the back. We're still doing elimination and we still need the same coefficients. So if we kind of look at what the problems look like here, these are examples where you might have to change both equations. Okay, so if I look at D, X's I've got 3 and 5, and Y's I've got 5 and 7. For the X's, I can't multiply 3 by something to give me 5. And for the Y's, I can't multiply 5 by something to give me 7. So I'm going to have to change both equations. So you're going to have to multiply both of them. And you just need to pick, do you want to get the X's the same? Do you want to get the Y's the same? The X's are smaller numbers, so I'm going to go there. And I just multiply them by each other, 3 times 5. Let's aim to make them both 15. So if I multiply the top equation by 5, I'll get 15 in front of X. And if I multiply the bottom equation by 3, I'll get 15 in front of X. Think about the signs too. They're both going to be positive, so I just need to make one of them negative, and it makes no difference. I'm just going to choose the 5. Okay, so I need to distribute and times everything by something. So the top equation, when I distribute -5, that's going to give me negative 15x minus 25y equals -50. In the bottom equation, I'm going to get positive 15x plus 21y equals 30. Now I'm ready to add them together because I see -15 and positive 15. So the x's will eliminate, that's 0. -25 plus 21 is going to give me -4y equals -50 plus 30 is -20. Okay, when we divide here, we get y equals a positive 5. And then you guys already know we got to come back up top and we got to plug in 5 somewhere. Realize you could plug it into the original 2 equations, or you could plug it into one of the new equations. My advice would be plug it into one of the originals because they're smaller numbers. So I'm just going to go with the very first equation, 3x plus 5. I know y is 5, so I'm going to plug that in there. 5 times 5 is going to give me 25. And then if I subtract 25, 3x equals -15, and divide by 3, x is -5. Okay, one more. Now, let's see. Again, take a step back and analyze. I see 3 and -10 in front of x, and 2 and 5 in front of y. I can't multiply 3 by anything to give me 10, and I can't multiply 2 by anything to give me 5. So I know I'm going to have to multiply and change both equations. Here's what I might notice. I see that in front of the x's, it's already positive and negative, so the signs are what I want. So I'm going to choose to change the x's, but you could go for the y's, make them both 10. I'm going to choose to make these both 30. And I just do 3 times 10, make them both 30. So if I multiply the top equation by 10 and the bottom equation by 3, then I'll have what I want. Okay, so top equation will now look like 30x plus 20y equals -90. And distributing 3 to the bottom equation, I'll have -30x plus 15y equals -15. Now I'm ready to add them together. And the x's eliminate again, that's 0. 20 plus 15 is 35y. And then -90 plus -15 is -105. Okay, last step is divide by 35. And it should come out nicely. Y is -3. All right, last step is to bring it back up and choose one equation to plug into. Same thing, I'm just going to go for the first one. So 3x plus 2. I know that y is -3, so I'm going to plug that in there. So that's 3x minus 6 equals -9. Add 6, and then divide by 3, and you should get x is -1.